Good afternoon, Mr. Vivek Basin and Mr. Kelkar, and to all of you who are in the front of me. That's Rama standing on the reactor, killing the greenhouse gases. In fact, I had an US photo earlier. Somebody in US said that you should have the Indian photo here. Yeah, now the point I would like to consider is fossil 240 gigawatts, and India would have to add until another at least a decade some more fossil fuel plant to meet the criteria which I am going to tell later. We have not signed the fossil fuel non-proliferation treaty, so we're going to go ahead to meet the three criteria with fossil fuel for at least a decade more. There are three important requirements for energy for India and in fact for all the developing countries. One is to provide clean and affordable power to each of its citizens. In fact, that is what SDG 7, Sustainable Development Goal 7 says. Even to have a human development index of 0.9, you have to have 5,000 kilowatts per capita, whereas now we are 1,327. In fact, developing countries would like to concentrate on SDG 7, whereas developed countries would like the world to concentrate on SDG 13, which is on climate change. The power requirement is also for powering the fastest growing economy in the world, and also to meet the nationally determined contribution which India has submitted under the Paris Agreement. Nuclear is a unique source which satisfies all these three rather conflicting requirements simultaneously. This is something which is very unique for any energy source. We require 10 times the energy which is now 400. It has to go to 4,000. In fact, IIT Mumbai has submitted a report that we will require 24,000 to 30,000 gigawatts by 2070. Even globally, nuclear has to march very fast. It's the only bulk green dispatchable source. It is calculated by 2050, 90% of the power will be from nuclear. The countries, 22 of them, have pledged that they will treble the nuclear power capacity, which is now 370 gigawatts. It's taken 70 years to come to 370 gigawatts, and they have to treble it, which means add 740 gigawatts in the next 30 years. They have to break away from the stagnation which they had all these years. In India, there is no stagnation, but we have to greatly accelerate from what rate we are now in. I'm glad that renewables are growing fast, but the demand is growing faster. Until green capacity grows faster than the demand, we're going to have fossil fuel with this. Renewable has issues. I'm comparing here renewable and nuclear only, which are the two green sources. I'm not comparing with fossil because fossil is going to get phased out. One of it is what Mr. Srinivasan presented yesterday. We just don't have enough area to have the grid totally supplied by renewable. And one more fact is the potential for renewable is 1,000 gigawatts, whereas I just mentioned we need much more. The gap needs to be filled by another green source. There is another issue I'm just pointing out a few, not to tell that renewable should not be encouraged. It must be encouraged as much as possible. There is a thinking that nuclear is capital intensive. And when you come to renewable, it is not so. For example, renewables capacity factor is 20%. Nuclear is generally around 80%. In fact, the 100 reactors in USA is running at 90% capacity factor. In fact, I would like to quote the 2021 report. Nuclear with 1.6% installed capacity supplied 2.7% of the total generation in India. So to deliver the same megawatt hours, you have to install 4 times the installed capacity of a nuclear. So that's number 4 already. The life of solar plant is 25 years. The life of nuclear plant, already subsequent extension has been gained to many US reactors for 80 years. In fact, DGIAA thinks reactors can last for 100 years. I mean, within the life of the reactor, you have to build solar 3 times. So that will be 4 into 3, 12. Then the third point is energy return on energy investment. If I spend 1 megawatt hour to make a solar plant, it gives 1.6 megawatt hour. You just gain 0.6 megawatt hour out of it. In fact, that's the ratio, 1.6. For molten salt reactor, it is 2000. For light water reactors, it is 76. Then there are system costs. If you add all these things, I don't think nuclear is capital intensive. Nuclear and renewable are favorable twins. And we have to do many things in the world now which we have never attempted before. This is something of a big challenge. These are the commitments which India has made. I won't read all the commitments. These commitments have been made in spite of India being only 2.8 tons CO2 per capita, as against 17.6 by US. So the per capita is very, very low. But since the population is high, the total ton is not negligible, which is why India is ready to make these commitments. These commitments would require massive decarbonization. I think India and China will lead the global renaissance with SMRs leading it. In fact, the success of climate mitigation globally depends on what China and India does. We need big reactors and small reactors. Big reactors for power production and for long-term, larger mitigation. Smaller reactor for faster mitigation. And probably more on non-power usage. Why SMRs? I think many people have already covered this. SMRs rose from the ocean. We have 180 reactors operating at some time or other, and more than 13,000 reactor years. They are safe, they are proven. And in fact, the present SMRs, which are now going to come online, use the same fuel, is just like any light water reactor. They have more than 30 advantages. I'll let you read the advantages except at those places where I want to elaborate. For example, it is load following, flexible, ideal for hybrid with renewables. And SMRs are such that even in a severe accident, now called design extension conditions, there will be none or minimal emergency countermeasures that will be required in the public domain. But let us reconcile one thing. If somebody asks, we can say that nuclear energy will never be absolutely, perfectly, guaranteeably safe, because nothing is. If you're going to, there is a limit to which you have to do, and you must do the cost benefit. They have, I'll let you read the remaining things. I go to I'm sorry, I'm making you work quite a bit. SMRs are ideal distribution energy source, which is what is required for bulk decarbonization of many non-power CO2 emitters. It's vital for just transition, which I'll be explaining a little later. Generally, they are located underground, which takes care of nuclear security as well as public exposure. They are underwater, like what our PHWRs are. And from now, I'm going to call our PHWR as INDOs, as against CANDOs. True, it does not accrue the advantage of scale, like a 1,000 megawatt reactor would probably cost less per megawatt. But there are many issues which need to be considered. For example, they have lesser interest during construction because they are supposed to be built in 3 years. The civil construction normally is 40 to 50% of the construction cost, and for SMRs it will be much lesser. When you repurpose it with a coal plant and use part of the infrastructure, the cost will come to 30 to 35% less. And one important thing is the upfront cost. The upfront cost is such that many countries can afford it. In fact, here we have a paradigm. Those who can afford nuclear power, the bigger nuclear power, don't need the bigger one because their demand increase is 0.5% or something. So they go for smaller reactors. And those who cannot afford big, they go for smaller reactors. Ultimately, the smaller reactors become the winner under these situations. Due to the above, SMRs can decarbonize by supplying power and process heat. And many people have brought many other applications to many other things, which in fact is more than 50% as far as CO2 emission is concerned. There are hard to decarbonize industries like steel, chemical, petrochemical, which use process heat and power both. I want to give an example of Dow Chemicals and ArcelorMittal, who are investing in natrium and other reactors so that they can use these as captive plants in their factories. Tata and JSW are introducing hydrogen in their blast furnace. Many countries are going for green steel projects. These are some of the things which the recipients of nuclear are also doing. Multiple deployment in desalination, you can see the list, but I would like to elaborate on hydrogen, which many people, we had a very good presentation on hydrogen just before in the morning. Hydrogen is the game changer. It's a wonderful carrier, and as mentioned by many people, National Hydrogen Mission calls for 5 million tons per year. A 1,000 megawatt reactor can produce 200,000 tons of hydrogen per year. Globally, it is now 80 million tons, which is going to go to 700 million tons by 2050. I feel India can be a hydrogen hub. NPCL mentioned that they are going to have hydrogen production at RAPS location and TAPS location. Oh. There are challenges. There are policy and regulatory issues. I just want to tell a few of them. The main thing which I am really worried is majority of clients which the nuclear will have from now onwards will be those who had nothing to do with nuclear until now. And this is going to be a very big challenge, especially in adapting to each other, which I'll tell a little bit later. The challenges are in the area of industry, regulation, policy, market, infrastructure. I'm going to talk something, and you may be surprised whether a regulator like me is talking these things. The regulatory readiness and faster and bolder regulation and harmonization. In fact, I was a little bit scared whether Chairman AERB will be in the panel and whether I'll be able to talk whatever I want to talk now. I think Vivek will be able to cooperate with me there. Anyway, the word says think local and act global. I want to elaborate one very good practice with Atomic Energy Regulatory Board is doing, which is the concurrent regulation, which is ideal for those reactors which take 5 years or more. In fact, for Narora Atomic Power Project, this was practiced. We had 500,000 technical manpowers to review, and we even put in an extra system called GRAB, gravity addition of boron, which was used during the Narora fire accident. In fact, I cannot recollect even one license being delayed by AERB, and that is without sacrificing the depth of review. For SMRs, of course, you can't have concurrent regulation, you have to have prior design certifications. Here I'd just like to point out that how in many areas India is ahead of the world. One is, of course, the concurrent regulation. The other thing is, in 2005, we modified many of our reactors. The modification included locating all the safety equipment above the flood level, re-reviewing the older reactor for seismic tolerance, and the world did it in 2011 when the Fukushima took place. One other example, we prepared what is called at that time Operation Procedure and Emergency Condition in 1978, which was called as Emergency Operating Procedures by the world, and they prepared 1 year later in 1979. Just to say, we are ahead, but we have still areas where we have to learn. The challenge includes in siting. I read a US NRC report which says, considering the plume exposure pathway, we can have the site boundary for SMRs as the exclusion zone. Ingestion pathway is site specific, so they have to again prove that ingestion dose also will be within limits. They have to be designed in fact for higher seismic isolation, because SMRs are going to be located at urban areas, at load centers, at places where it is required. So there is a lot of regulatory procedures that, of course, taking care of safety and nuclear security have to be revised. I have a small suggestion in our sterilization zone. In fact, this suggestion was given to me by Collector of Chengalpattu, who was the emergency director there. He said, what are you worried about? You are worried about that emergency countermeasures like sheltering, evacuation, iodine tablet distribution. I will prove to you, with any increase in population, in every 2 years when you do the emergency exercise, that I can carry out this in front of an AERB observer. So I have a feeling that there is scope for doing this consistent with, of course, safety. They have to have harmonization. I have been talking to AERB. In fact, there are many organizations like International Nuclear Regulatory Association and CORDEL. IAEA has got their own. WANO, we have a bilateral arrangement with many countries. So there are several avenues for AERB to harmonize themselves. And harmonizing with international benchmarks gives it some sort of a In fact, it's a very big public acceptance measure. To have their own circular economy. In fact, in our case, the back end is in fact front end for the next stage. And I have a feeling that ENR restriction by NSG is completely reversing the logic of nuclear deal. I consider reprocessing as turbine generator, something in many nuclear power plants, the reprocessing is located next to it. If somebody gives me just the reactor without turbine generator, I can't generate power. The world energy suppliers knew that we have reactors, but the fact that they told that we will give you some more reactor is to make it faster. Like that, we may have reprocessing capability, but we wanted more reprocessing capability to multiply faster, not for anything else. In fact, I understand China has been given a 800-ton reprocessing plant. I mean, I'm not trying to compare. So this has probably put us into trouble in the sense we're not able to reprocess now those reactors which are under safeguard and IAEA safeguards and other reactors which are imported, which needs to be done so that, as I told you, it will be the feed for the next generation plant. We also have issues on high-level radioactive waste, which is also part of the circular economy and many other things. I will skip some of it because of lack of time. But I would like to say that the waste, EV waste from solar panels is now 5,000 tons. It's going to be 4 million tons by 2050. And I have not seen any recycling or final disposal of this waste. Supply chain and indigenization, I won't talk about supply chain, but on indigenization, the present SMR, as I told you, is okay, no problem, because it used the same fuel as the LWRs. But when you go to advanced reactors and advanced SMRs, they will be using, and for safety, they will be using accident-tolerant fuel. They will be using HALEU, TRISO, and all these things. And the manufacturers are talking about manufacturing kgs, whereas we need tons. In fact, natrium reactor has been postponed by 2 years because of lack of this supply chain. I'm glad to say that I've talked to L&T, somebody may be here, and Godrej. They said they can make 20 SMRs per year. And there is a calculation which says it will be 30% cheaper than anywhere else in the world. Maybe compared to Korea, it may be 20% cheaper. In fact, Westinghouse have a thing that make where we build. So here opportunity is, I have coined the word sabbatical. In fact, many countries like US, they've gone into sabbatical because they didn't build anything after 1979. They don't have, other than designers and operators, they don't have constructors, they don't have manufacturers. In fact, I think Westinghouse, if I'm right, have given contract to Doosan for manufacturing probably the pressure vessel itself. So I think they will be very, even Russia, which is a leading exporter, is almost, if I'm not mistaken, right up to the neck. In fact, we are helping the Bangladesh plant with some construction activities. So there is a tremendous scope for Indian exporters. The fact that the Kaiga plant manufactured by Indians operated for 1,000 days without even looking at them is a testimony for Indian manufacture. SMRs will be located in urban areas, and so this would require a lot of regulatory and also safety calculations. Public and social acceptance is very, very impact. In fact, I think we are lacking a little bit on public information, and I'm in fact surprised and a little bit pained to see people go to judiciary when, for example, our own regulatory bodies are there. The regulatory bodies should be held in high esteem, and they should have enough confidence in them. And this can only come by public information. In fact, 95% of the people are such. And in fact, I want to say, these 95% are media people who are fair. One should not question their question. Go ahead and answer it, and to the extent they can follow, to the extent you can tell, and they will buy it. Remaining 5%, don't bother about them. You can't correct them. In fact, I have a joke, if there is time in the end, I will tell. But one sentence I will tell is, you can wake up anybody who is sleeping, but you can't wake up somebody who is pretending to sleep. So you forget about those 5%, but do a good job on the remaining 95%. Grid resilience, stability, optimum and more flexibility. The quality of power is defined with good frequency, good voltage, and no interruptions. You may have a high capacity factor, but if you are interrupting 10, 12 times, I know I was living next to heavy water plant in Kota. If the power fails, then they are out for 2 days. I think Director BRC will be able to tell how many chemical plants cannot afford. So the nuclear power plants stand like a rock on grid disturbances. I was traveling once from Delhi to Bombay. It travels over Udaipur and our own nuclear power plant. There was a big northern grid disturbance. Whole of north was dark, except Udaipur, which was well lit because it got islanded with Rajasthan unit, which was still operating. So I want to talk about one nation, one grid. This will help a lot. And with nuclear power plants, I think if we have enough nuclear power plant, the battery storage is not required at all. And pump storage and battery storage are against the principle of entropy. You use energy to produce them, and again you get energy from them. You always lose things. Coal reprocessing and just transition. Have I got 10 minutes?
Yes.
Okay. Is emotional. It's reskilling, reshaping of the economy. So it's not going to be an easy thing. It's not just technical. So while you do repurposing of the coal, you can use a lot of things. For example, you can use their switchyard, you can use their water treatment plant, compressor plant. You can probably use their heat sink also for our ultimate heat sink. In fact, Holtec has, I understand, with compressors, increasing the steam condition so that it can feed to the existing turbine generator. In fact, I was there in operation for a long time. 70% of the operation manpower, operation and maintenance, are in the conventional areas, on turbine generator, water treatment plant, diesels, and they can be reused. And it doesn't take much training for the remaining 30%. People who have worked for 30 years, 40 years, you can't just throw them out. They have family commitments. Here, I thought India should come out with a guide which includes siting analysis, technical compatibility, techno-economic analysis, suitability for SMR and big reactors, decision-making issues, workforce transition and workforce reuse. See, I think we should have a format which we can put across for each of the plant to find out. I don't think there is a document of this type. I'm sorry, I talked about 5.1. This adaptation is something which I talked earlier, and I am, hope unnecessarily, worried about decarbonization of the non-power areas. In fact, I had told earlier, I'm going to tell in the panel also, that as far as CO2 emission is concerned, power is a junior partner. The other non-power sectors are senior partners emitting much more CO2. And this is an area which is virgin, which, they don't know each other. The nuclear on one side which is supplying and other industries which are recipient. So it requires a lot of efforts. Nucleus need to be more flexible as part of adaptation, like you should have a turbine generator bypass, load following. The fuel must be robust because a lot of ramping may be there for hybrid operation with in the grid. The islanding scheme which we have is very good. I talked about Holtec. In fact, some reactors are designed for air cooling because 90% of the power industry is water sensitive, and I am not very sure whether water will be there for all the time to come. Then I feel that we should also go for our own CHTR. This is high temperature reactor. Somebody talked about it later. And Indian molten salt reactor. In the panel, I will talk about the attributes of molten salt reactor. We need higher temperatures, so molten salt reactor and HTR can give higher temperature for process heat for various industries. Cogeneration will help improving the efficiency. The recipients, Dow Chemical is already trying to see whether they can lower the temperature required for the process heat in their factory. Hydrogen, I said, is very important, but there are a lot of issues. I think somebody brought the cost. I think ultimately you should have $1 per kg. So there is a lot of work that need to be done for it to do. If I am hydrogen, I would have compared bitterly against the world. It's a colorless gas, it's a humble one, and I think now we have 8 colors for the hydrogen: blue hydrogen, green hydrogen, red hydrogen, and all this. I think India should call the nuclear hydrogen as green and try to convince IAEA to do the same. There is a tussle, of course. I was talking during breakfast time in EU between one group and another group. One group wants it to be called green, the other group doesn't want it to be. Then they have to develop competency, even if they are not operating the nuclear power plant or SMRs next to their factories, because they are too near the nuclear plant. There are more than 17 competencies I have listed. And here again, I would like a guide to be prepared to completely make a format for adaptation between the two. The 3M that is required is enormous, 3M being men, material, and money. Just take human resource development. In India, it takes 8 years to prepare a shift charge engineer who are normally licensed by the regulatory board. And if SMRs are going to be built in 3 years, you have to start 5 years ahead. And we need simulators. The AERB insists that simulators should be there for training the shift charge engineer and the first operator. So the supplier has to make sure simulator is available 5 years before construction starts. More organizations will definitely multiply the resources. I was the chairman of a FICCI committee on privatization. In fact, we made a lot of things, including a roadmap from 26% minority share to 100% minority share, how to develop the competencies, public-private model and other models. And we submitted the report to DAE at that time. Mr. Kakodkar was the chairman. I think privatization has to come sometime or other. It's just to multiply the resource. And the in-space model or the research reactor model with a little bit modification would be okay for power reactor model also. I am actually enabled by one method which is called RAB in UK, which is very nicely tailored for cost and risk sharing, and private people will not come unless this is done. Okay. What do I do now? This is why I want nuclear power, so that we don't have any interruptions. Yeah. On this taxonomy green bond, Government of India has got a scheme of productive linked incentive, and I don't think much will come from the $100 billion per year that has to come from developed countries for climate change mitigation. Just now they have approved loss and damage, but modality of this also has not been there. I am surprised why multilateral development banks like World Bank and IMF are not giving. Right now, the climate is good. Climate means something else, not really climate, for nuclear. Greta Thunberg has criticized Germany for phasing out nuclear and continuing with coal. Miss America is all for nuclear. So we have a good climate. I understand nuclear was not declared as a clean development mechanism because of three things: proliferation, safety, high-level radioactive waste. And all these are being addressed. I think we must fight to get nuclear as a clean development mechanism. The advantage is, if Westinghouse put a reactor in India, they can claim it against their nationally determined contribution. And this is going to help. This is going to help a lot. I don't think we can have climate change mitigation efforts and meeting of all indices of all the 197 countries who have signed these indices unless such things are done. We're going to be stagnant otherwise. But of course, easily said and done, it requires a tremendous push. In fact, we can see in COP28 the pledging of nuclear. These are all good signs. I think finally I want to say that India can have 4 streams, all fleet mode, 700 megawatt reactor. CMD mentioned that they are trying to standardize them. Imported light water reactors, fast breeder reactor, and both indigenous SMRs and imported SMRs. Sometimes I read a criticism that we are neglecting Dr. Baba's 3-phase program. Dr. Baba's card number was 3333. The first 3 for 3 stages, and the last 3 is for additionalities to imported reactors. I don't think he was against imported reactors, because he agreed to, he in fact recommended import of Tarapur. So the imported reactors are additionalities. The sea tanker would remain the 3-stage plan. They are like, say, Virat Kohli or Sachin Tendulkar for us. The remaining ones are the other batsmen and bowlers. For the imported SMRs, I don't want it to be, my idea is that it should not be what BPER contract or Westinghouse or EDF contract are likely to be. We have to have a 3-step contract. One, for progressive localization. In fact, we had an MOU with KEPCO when I was in a private company, and we drew up a wonderful localization plan. Localization is to be optimum. If you try to localize fast, our companies cannot supply equipment in time and there will be construction delays. So you have to see the pros and cons. But we must have localization. Then B, third-party bidding for other countries once localization is done. And C, absorb the technology and bid independently to the other countries. In fact, this is a win-win situation for supplier too, because there will be a competitive bidding in third countries after some time. I think we should not worry about cost of the first few units. This is one of the things which probably is stopping the deal with EDF probably. It will get amortized. The third unit is only 50 to 60% cost, and third party and sole we will be able to export, and we are already doing a third party the situation in Bangladesh, and our equipment is 30% cheaper, and as I told, it can be competitive bidding in other countries, and as I told, it's a win-win situation. Yeah, yesterday, I think sometime I told nearly 50,000 megawatts of captive fossil plants are in private industry, and they would, somebody mentioned about the carbon border tax, and so they probably would like they're supplied with the green energy, and they want small PHWR out of 3 SMR, yes is there for PHWR, 220 megawatt ones. But there may be desirable to do some things like probably have double containment with steel liner. I don't think we have to do everything to make it generation 3 plus like 700 megawatt reactors, because the PHWR are the safest reactors in the world. I have several reasons to tell that, but there is no time now. So, if they can build in 4 to 4.5 years with part modularization, project management improvement, I think the private industry will be very much tempted. In fact, we have a 1,000 megawatt CANDO reactor Monarch, which is modular based construction strategy, flexible siting, okay for coal plant locations and hydrogen production. So many countries also would like to import 220 megawatts. So these Indus are wonderful, established world records, safe, viable, reliable, and cheap. So they will be very good competitors for export. I already talked about CHTR, this one. AHWR, I was a pre-licensing review. It's a wonderful reactor, but for some reason, we're not able to go ahead. LTO, long-term operation, is the one which is being done in many countries, in India too. PHWR has a tremendous advantage that the pressure boundary is getting replaced every 20 to 25 years when we put new coolant tube, which are the pressure boundary in PHWR. So I think, and the cost will be less than half of a new build. So, and I told you, DG thinks it's 100 years. I think some CANDO reactors claim 100 years. One more thing is these old reactors, as far as capacity factors are concerned, are as good as new. I keep telling, I am 85 now, I play tennis, I don't get defeated by young people. So the old reactors are very similar to me, I should say. Very sturdy, incredibly safe, and very good performance. In fact, I understood RAP3 has done coolant channel replacement in 51 days, which is almost a world record. I mean, world means PHWR record. I feel the NSRA bill with that modification has to be passed. It's okay if NPCL alone or the licensees, but when private companies come, it's a different cup of tea. I feel we should amend the Liability Act. I think insurance pool is not going to work. Let me be frank about it. The suppliers are worried about tort law, and Bhopal is in front of them. It's very good for compensation, but not so good for the nuclear industry. So we must bring it in line with the IAEA or world practice of Liability Act. Atomic Energy Act may require modifications. I think Srikant brought out wonderfully all these things. For privatization and perhaps for FDI too. And also, I think AERB should feel comfortable if they give license to any other PSU other than NPCIL. So all these things need to be thought about. Faster use of thorium, 358,000 gigawatt years is available from thorium. India not using thorium is like Arab countries not using oil. Many advantages, I don't have time to tell. And AHWR, I found it's a wonderful reactor, not only for India, but even for export. I'm wondering whether we should concentrate on time. Okay, I'll go to conclusion now. 2 minutes for conclusion? Oh. Yeah. I talked about marrying with strangers, which is nuclear plus recipients of nuclear who have never had to do anything with nuclear earlier. I thought the high-level standing committee with adequate powers and expertise in each sector which needs to be decarbonized is there. There is an energy transition working group. And the thing that is going to talk about, I talked about the change of reshaping the progress and everything. In fact, 4 Fortune 500 companies in India are going to disappear after 2070. So these are the things which we are going to do. We have to be in mission mode, do things which we have never done before, and we should have world as one country. In India, we have a word called Vasudhaiva Kudumbakam, the whole world in one. Unless the whole world behaves like a country, I don't think we can have the things. Balance, ecology and economy, this is what the Prime Minister said. India is one of the few countries who are going to meet their indices. I think Indian model is emulatable by many countries. Finally, I would like to say that energy mix in India during the transition has to be on 4 pillars. Fossil, which will have to be gradually phased out, but in the meantime, build only ultra supercritical thermal plants. If possible, have CCUS or use gas as bridge fuels, renewable including hydro, 4 streams of nuclear and other reactors which I mentioned, and energy conservation, demand side management, energy intensity, which is kilowatt hour per unit GDP, T&D losses, smart grid. And again I would repeat, we would like world to be one country and each other helping just like family members. Otherwise I don't think we can achieve. Thanks.